So today we're finding the maximum height of a projectile. And now you guys can go and copy down this. Okay, so this is review. The question at the top says, remember how to find the vertex. So, and the steps are off on the right side. First of all, the vertex, in case you guys don't remember, that's the point where our graph turns around. So if it's an upside down parabola like this one, it goes up and then it reaches the highest point and then it goes down. All right, it could also be going the opposite direction. Now in this case, that's as high as our parabola reaches, so it's also known as the maximum point. It's also known as the turning point because it turns around. Up until that point, it's rising and rising and rising and rising. And then when it gets here, it starts to fall down again, so they call it the turning point. So that point has three names: vertex, maximum, or turning point. Okay? Now, let's remember how to find the vertex of a parabola. You start using this thing over here. Does anybody remember what this formula is called? It's the axis of symmetry. We start by using the axis of symmetry, which is the line that cuts the parabola in half, by the way. That tells you the x value. And then to find out what the actual height is, you plug that in to find out what the y value is. And that'll tell you just how high up the parabola goes. Right? So when we're dealing with projectiles, guys, how do we find out how high the projectile goes? Well, look at our graph. Our graph is not x and y like it is when we've been doing parabolas. It's time and then height. We'll use the letters t and h, okay? All right, so the axis of symmetry would tell us our x value, but our x value is what this time? It's time. So t, you can find the time it takes to reach the maximum height as negative b over 2a. Let's go ahead and label that now. This is a very special time. It's not just any time. This is the time it takes to reach the maximum height. So how long will it take to reach the max? So on your test, if I were to ask you, how long would it take this projectile to reach the maximum height? All you would have to do is use negative b over 2a. That tells you how long it takes. Now, if you want to actually find out what the height is, you just plug in your time into the formula, negative 16 plus vt plus h, which we've been working with for a few days, and that'll find you your h. So, there you go. All right, let's go ahead and copy down our first example problem for this. Let's do it. A rocket is launched with an initial vertical speed of 400 feet per second from a starting height of 3 feet. Find out the maximum height and how long it takes to reach the maximum height. So we're actually looking for two things here. So you can imagine this as like a rocket that's starting off on a tabletop. There's the table. And then we'll draw a rocket here. All right. It's 3 feet off the ground. And it starts off at a speed of 400 feet per second. And then it lands on the ground. And our question is, how long will it take to reach that height? So we're looking for the time. And we're also looking for just how high it goes. So how long and how high will it go to reach that height? All right, so let's go ahead and label our numbers here. Since we're dealing with vertical, once again, we're going to use our formula for vertical speed and whatnot. So a rocket is launched with an initial vertical speed of 400. What's that number going to be? That's our v, our velocity. From a starting height of 3, that's our lowercase h. Find out the maximum height and how long it takes to reach the maximum height. So here we go. We have negative 16t squared plus v, which is 400 t plus lowercase h, which is 3. And we don't know what big H is yet, but we will. So we have two letters there. We have T and H. And our goal is we want to find out what the maximum height is and how long it takes to get there. So, to find time of max height, what do I use? T equals negative b over 2a. So, what is my b? So it's negative 400 over 2 times a. What is a? Negative 16. So I've got negative 400 over negative 32. And on your calculators, if you guys could do that and then round it to the nearest tenth place. So 12.5. In other words, now let's stop here for a second. I'm going to label this as seconds because it's our time. That's our first part of our answer, how long it takes to reach maximum height. So what is that? That means if I were to launch a rocket with that speed, in about 12.5 seconds, it would reach the maximum height. At that point, it's going to start falling down. Okay? But up until then, it's climbing higher and higher and higher. All right, moving on to the next part of the question, because this is only the first part. This is finding the time. Okay. So our formula was negative 16 t squared plus, was it 400, guys? 400t plus 3 equals h. Now we just found out that the max time, I'll put t with the words max here, is 12.5 seconds. So it takes 12.5 seconds to reach the maximum height. So to actually find the maximum height now, we plug in 12.5 for the time. And since there's two t's, you're going to be plugging it in twice, right? All right, so from here, guys, you're just going to follow through the order of operations as we always have. Which one do I do first? Squared. You do the square, so 12.5 squared. We're getting 156.3. Okay, then we do our multiplication. 156.3 times the negative 16 is negative 2,500.8. And then 400 times 12.5 is 5,000. And then from here, we're just going to use our calculator to add and subtract those three numbers. So here we go. Negative 2,500.8 plus 5,000 plus 3. And we're getting 2,502.2. And what do you think that is? It's h. So what do you think the units are? It's just feet, the height. In other words, assuming that we had a rocket that really went that fast, that's pretty darn fast. Assuming we had a rocket that did that, what you're looking at is it would be reaching a height of 2,502 feet in 12.5 seconds. Okay? That would be pretty fast. All right. Okay, guys, so I'm going to give you one to try now on your own. Here's one for you. We can find the amount of time it takes for it to hit the ground. That's what we just did last class. But let's not worry about that right now. Let's go ahead and just focus on how long it takes the bullet to reach the max height.